Hello there, Mr. Chan here, about to do another lesson for Algebra 2, Lesson 2-6, the Quadratic Formula. Please open your note takers, the Student Companion, to page 53. 2-6 is the Quadratic Formula. It's a formula that is used to solve any quadratic, including ones that might produce decimals and fractions and radicals, and even imaginary numbers. Crazy. The beginning of this lesson, we start out with ax squared plus bx plus c, and they set it equal to 0. Setting it equal to 0, this is where you look for the roots, zeros, literally the x-intercepts of the quadratic equation, which is referring to the parabola. Part of this proof that they give us here of the quadratic formula includes completing the square. That's what they did there. And lo and behold, after doing that, completing the square, we produce something called the quadratic formula. Back in the day, we used to be asked to memorize this formula. I've heard of a song. I don't remember at this point, but I remember the phrase, if you follow along with the formula, a bad boy couldn't decide, there's your plus or minus, couldn't decide whether to go to a radical party. He thought he'd be square about it, the boy, b squared, but he missed out on 4 awesome chicks. The party was over by 2 a.m. That's what I memorized back when I was a student. That's what the teacher told us. Okay, one important part about the quadratic formula, which will produce any answer, by the way, is the stuff or the expression underneath the radical. In this case, b squared minus 4ac. There's a name for that. That's called the discriminant. It sounds like discriminating, doesn't it? In fact, it is kind of like that. There are 3 scenarios that can happen with that particular value. If the discriminant, b squared minus 4ac, is greater than 0, meaning positive, you will produce 2 real solutions. Mathematically. Those real solutions are referring to how a parabola crosses the x-axis. So I'm just generically drawing one that can happen. There's one real solution right there and the second one. What happens with another scenario? If the discriminant equals 0 itself, that means the parabola hits the x-axis only once, meaning there's only one real solution. And it looks like this. Could be a parabola that's right side up or upside down, but the point is it crosses the x-axis only once. Right there. And you already probably guessed what's the third scenario. What happens if you get a negative discriminant? Well, you'll get 0 real solutions, meaning this particular situation is a parabola that floats above the x-axis or below the x-axis, but never crosses it. Okay? In fact, when it doesn't cross the x-axis, we consider this to have two imaginary solutions. And that's the key. Two imaginaries. All right, let's move on to the next section here. What must be true of the value of b squared minus 4ac if the equation ax squared plus bx plus c equals 0 has two non-real solutions if it has just one solution? Oh, we kind of talked about that already. Two non-real solutions is when the discriminant is negative. One real solution is when you have the discriminant to equal to 0. We talked about that up here. And literally, what we're referring to is when you have the square root of the number 0. When you add a 0 or subtract a 0, you get the same number either way. That's why it's a single answer, not two answers. In fact, that's called the double root. All right. Let's go ahead and move to the next page and just try the quadratic formula. Here we go. Let's go ahead and write down the quadratic formula. X equals to negative b plus or minus the square root of b squared minus 4ac all over or divided by 2a. As long as your quadratic is in standard form, ax squared plus bx plus c, you can just plug it in here and that's all you have to do. Let's go and identify a, b, and c for number 1a right now. Let's do that. A is equal to 2, nice. B equals 6, and C equals 3. Plug it into that formula very carefully, like a recipe. B squared. What I like to do is write the formula without the letters in there first and then plug the numbers in, just to be careful. So negative b equals negative b plus or minus the square root of b squared minus 4a, in this case the number 2, times c, which is 3, all over 2 times a. And all you have to do is clean that up very carefully. Underneath the radical, this is where some kids run into trouble. You want to clean up the discriminant as if it's its own thing. 6 squared is 36. The back part is where some people run into trouble. That whole thing right there is minus 4 times 2 times 3 all together. So negative 4 times 2 is negative 8, times 3 is negative 24. You have to look at it as one single operation right there, okay? 2 times 2 on the bottom, of course, and the denominator is 4. And 36 minus 24 inside the radical is 12. Now, if you left the answer like this, you would be partially marked wrong. You have to simplify the radical as well as reduce if possible. Yeah, the fun doesn't stop here, does it? 12 can be broken down further. Let's do that. We have 2 times 6, and of course 2 times 3. There it is. 12 is 2 times 2 times 3, and the pair of 2's come out of the radical. And that will give you negative 6 plus or minus, the pair of 2's comes out as a single 2 from the radical, root 3, there's no other pair there, all over 4. And even here, you might be dinged, because look at those numbers that are on the fraction, 6, 2, and 4. You can factor out a 2 in the numerator. Let's do that. When you factor out a 2 from that binomial, you'll get negative 3 plus or minus 1 root 3. You don't have to write the 1 if you don't want to. remember what I just did. I did like backwards of taking out a greatest common factor right there, and that was 2, okay? And that allows me to reduce it with the 4 in the denominator. 2 goes into 4 twice. So now I have -3 plus or minus √3 all over 2. Or if you put it into separate parts, that's allowed as well. Either one of those are correct. Normally you couldn't possibly factor this with a box or a diamond method or AC, because look at the result, we have radicals, right? Those methods are used for ones that factor nicely. This one would never have factored nicely. All right, let's try B. Same process, identify A, B, C. A is 3, B equals -2, and C equals 7. Let's plug it into the formula. I'm just writing the shell of the formula right now. All right, let's plug it in. Here we go. All right, -b, ooh, double negative right there in a moment. We have to make that a positive, right? Equals to blah, 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 -b squared there, minus 4ac, all over 2a. Clean that up. Double negative, I said a second ago, is +2, plus or minus the square root of. -2 squared is +4. Be careful here, multiply all 3 of them at once. -4 times 3 is -12, times 7 is -84. Uh-oh. We have a situation here, folks. All over 6. I have a feeling we're going to run into imaginary numbers. I know, crazy. 4 minus 84, of course, is -80. Let's break down -80 very carefully, including -1, 2, 2, 2, 2, 5. Do you trust me on that? Do you trust me that 2 times 2 times 2 is 8, times another 2 times 5, which is 10? It works. Look for pairs. Here's a pair of 2's, here's another pair of 2's, and that -1, remember what the square root of -1 was? It's been a while. The square root of -1 is described as the imaginary unit I. So this particular parabola is a floater because the discriminant is negative. Just remember that. The discriminant's negative. Let's keep going. The rest is arithmetic. So we pulled out a single 2 and another 2 and an I because of that square root of -1. And we do have a leftover number 5 in this case. All over 6. Yeah, you see it too? You can factor out a 2 from that mess, leaving with a 1 plus or minus 2i √5, right? There's a 2 and a 2 that we just took out right there, meaning factor out a 2. All over 6. 6 and 2 reduce to a 3. This gives me 1 plus or minus 2. I'm going to put the I in the back. I know that's going to look kind of funny, but it's traditionally right there. All over 3 is an answer. Or you can write it, separate it into the real part, add it to the imaginary part. Wow. Look at that. Crazy. Okay. Whew. So that is a situation where the quadratic formula was needed. Now remember, the quadratic formula is actually just a formula that solves all of them, but it's not necessarily the most efficient sometimes, because in the next problem, something interesting goes on. They want us to do number 2. Any questions on number 1A, 1B? All right. They want us to do example 2 more than one way. All right. Identify A, B, and C. Here we go. A is 6. B is 1. There's a missing invisible number in front of X. And C, of course, is negative 15. Let's use the quadratic formula. Here we go. Let's plug it in. B is 1. A is 6. And C is negative 15. Interesting. Negative 1 plus or minus the square root of 1. Now, this is a big number. 4 times 6 is 24. 24 times 15 is 360. I know. How did I get that so fast? I have the answer in front of me right now. Aha. And then add the 1 to it. I had to look this one up. The square root of 361 is actually a perfect square. Crazy. This perfect square is 19. Wow, crazy. Split that up and solve. Negative 1 plus 19 over, whoops, wrote that twice again. Negative 1 plus 19 divided by 12. Or negative 1 minus 19 divided by 12. So let's see, 18 twelfths or negative 20 twelfths. Let's reduce that. This gives me 9 6 3/2 or negative 5 thirds. Those are my two answers right there. That tells me that this particular problem can be solved using other methods that we've already learned. You guys ready to try that problem using the hybrid box method or the diamond method? Up to you guys. Here we go. I'm going to factor using the AC hybrid box method. First term, first box. Last term, last box. Middle term, lower left-hand corner. Great. Step 2, multiply the diagonal. Step 3, find the sum of the factors of that product that I just got. When added together, give me the middle term, in this case, x. So here I'm looking for the sum. When added together will give me x, coming from the product. Negative 90x squared. Let's think of all the possibilities right now. Of negative 90, here we go. Negative 190, nope. Negative 245, nope. Negative 330, I'm looking for 1 now. That's what I'm looking for. I'm looking for 1x. Negative, does 4 go into that? Yeah, it does. Oh my gosh. 4 and 20, maybe it doesn't. I'm kind of losing my mind here, Mr. Chan. Oh, it doesn't. Negative 5 and let's see, 18. Nope. Negative 6 and 15. Oh my gosh, is it really negative 9 and 10? There it is. There's mine. And make sure you throw in an x, by the way. Negative 9x and 10x. Oh my gosh. I think I could have guessed that. So put in the empty box. It doesn't matter where you put it. Last step, find the GCF of each row and column. First row, I can take out a 3x. Second row, I can take out a 5. That works. First column, I can take out a 2x. And last column, I can take out a negative 3. All right. Let's write the product. 3x plus 5 times 2x minus 3. Set that equal to 0. We do have the zero product property here that allows us to split those up and solve them individually. See where this is heading? And let's solve it. There you go. There's our first one. Yay, negative 5/3. Looks familiar over here on the right. We'll get the other answer after we divide by 2. Amazing, huh? Amazing. All right. Let's move on and answer some questions. Some more questions. Any questions about example 2 ways? Holy cow. That's a lot of work. Is it possible for a quadratic equation to have one real solution and one complex solution explained? Well, remember, we're graphing a parabola, if you want to see the solution that way. The parabola has to hit the x-axis. You cannot have only one complex and one real. It doesn't work that way. They have to come in pairs. So write that down. No, complex numbers come in pairs. Mainly because when you square root an imaginary, when you square root a negative, you'll get a plus or minus imaginary number. Right? When you take the square root of a negative, there's your two numbers right there. Make sense? Okay. Next question, example 3. Ooh, describe the nature. Okay, this is a little easier now. The nature is referring to the discriminant. The discriminant, of course, is b squared minus 4ac. That's all we have to do. As long as our equation is in standard form, I can pluck out a, b, and c from there. Here we go. A is 16. B, of course, for 3a is 8. And c is 1. Plug that into the formula. B squared minus 4ac. Plug the numbers in. And let's see what we get. Okay. 8 squared is 64. It's like doing the radical, you know, kind of a thing. 4 times 16 is 64. Oh, interesting. 64 minus 64 is 0. So imagine that being in underneath the radical, and there's a plus or minus. So it is a one solution situation because the parabola hits in one spot. I'm not guaranteeing that that's the picture of it. I'm just saying there's only one spot. This is one real solution. We also call that a double root. It's the same answer twice. Okay, let's do the next one. A is 2. B is negative 5. C, of course, is positive 6. Plug that in. Here we go. Now watch out for your order of operations here, please. It's easy to just mess up that negative 5. Negative 5 squared is positive 25. Minus 4 times 2 is 8. 8 times 6 is 48. Ooh. We get a negative 23. That's not the answer to the problem. That just tells us how many real roots we have because this is negative. Earlier this was 0. We have a floater somewhere, okay? It's a floater. It's floating out there somewhere. So this one has 0 real roots. or solutions, otherwise known as two imaginaries. All right. We are going to skip the next page and jump to the last page of this lesson. So let's do this for number 4 and number 5. And let's jump to the last page here. I know, this is nice. Nice review from Algebra 1. The discriminant and the quadratic formula. Here we go. Let's write that down again just in case we've forgotten it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's just do it. Describe the number and type of solutions of the equation. All right, they want us to look at the discriminant part. B squared minus 4ac. It's in standard form, very nice. All I have to do is plug the numbers in. Here's your A, here's your B, and there's your C. Nice. Plug the numbers in. B squared, 4ac. Not too colorful this time around. I just want to kind of finish up a little bit. 49, and then 4 times 2 is 8, times 11 is 88. Oh my gosh. We will definitely get a negative 39 value underneath the radical. This means there's no real solutions. We just have two imaginaries. It's a floater. All right. Let's try number 6 using the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac. Plug the numbers in. A is 1, b is 6. C, of course, is negative 10. Watch out for those negatives. Plug it in. B squared minus 4. I'm sorry. Negative b plus or minus b squared minus 4ac. Let's clean that up. $36. Ooh, watch out here. Negative 4 times 1 is negative 4, times negative 10 is positive 40. And that gives me 76. Looks like a big number that we can break down and simplify. 76, we'll do 2 times 38. Interesting. And 38 is 2 times 19. Interesting. 19 is of course, a number that can be broken down further. And let's go ahead and rewrite this a little more. Pair of 2's come out. Here's your pair of 2's. Plus or minus, okay, let me in front of that. 2 root 19 all over 2. Oh, look, they want us to reduce, of course. You can take out a 2 on top or factor out a 2. These are the negative 3 plus or minus 1 root 19. You don't have to write the 1 if you don't want to. I'm just doing that for emphasis. The 2's cancel out. And that leaves us with final answer of negative 3 plus or minus root 19. I like that. Clean, nice and easy. Still had to reduce, didn't we? Okay. Oh, number 7. This is kind of interesting. At time t seconds, height h of a ball thrown vertically upward is modeled by this equation. About how long will it take for the ball to hit the ground? So I'm just going to let you know, using a graphing calculator makes this problem very easy. Go to graph, and what you want to look for are roots. Another way of doing this problem is using also the equation editor. Put it in as a polynomial and let the calculator know its degree of 2. we know this is going to be a decimal. When you plug all that stuff in and solve for time, you pick the value that is positive. You don't want to pick the negative one. The answer you should get is 6.72 seconds. And because I'm on a video lecture here, I'm going to pull up Desmos and show you. Hold on a second. All right, here's Desmos. I went ahead and put in the equation, negative 5x squared plus 33x plus 4. It graphed a parabola. Let me zoom out. You can kind of see it. It's very skinny in this particular scale. But if I zoom in here, you notice that there is an answer here that crosses the x-axis just to the left of 0. That's your negative. Ignore that. But this is the one I want right here. Right there. Oh, look at that. 6.719. So that's really nice to have that technology to find that particular answer. Okay? Let's come back to the notes here and finish up. Here we go. Okay, so there's my 6.72 that I went ahead and rounded to the nearest 100th place. Last question of the day. Use the quadratic formula to solve the equation x squared minus 8x plus 16 equals 0. Is this the only way to solve this equation? Probably not. Let's do it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Of course, a, b, and c are right here. A is 1, b is negative 8, and c is 16. Let's plug the numbers in. I like to use the shell because it's easy to lose those negative signs very, very easily, and you can get the wrong answer. You just have to be careful. All right, here we go. Negative negative becomes a positive 8. Square root of negative 8 squared is 64 minus, negative 4 times 1 is negative 4 times 16 is negative 64. Interesting. 64 minus 64 is 0. Nice. 8 plus or minus the square root of 0 is still 0. This equals to 8 over 2 plus or minus 0, or simply 4 is your answer. They asked us, could we have done this problem another way? Yeah, very much so. You can factor by guessing and checking. You can use the box method. You can use diamond, hybrid. There's all kinds of things. Or, you know what else I just noticed? This thing is also a PST, a perfect square trinomial. This works. Look at this. Minus plus will give you minus minus when you factor a perfect square trinomial. And there it is, ladies and gentlemen. It's a double root. X equals 4 twice. Double root. This particular function, if you graph it on a calculator, will cross through 4 on the x-axis. It will look like this, folks. Okay? All right. Well, thank you for being patient. We are finished. Have a nice day. See you next time.